Alright, today we're going to be covering section 5.4, the fundamental theorem of algebra. So we're going to talk about the fundamental theorem of algebra. Yes, algebra has a point. The geometric meaning of zeros and multiplicities of zeros. The fundamental theorem of algebra. Every polynomial of degree n greater than 0 has at least one zero, real or complex. If we know that a polynomial p sub n of x with degree n has a 0 c sub n, we can divide p sub n of x by x minus c sub n to get another polynomial p sub n minus 1 of x with degree n minus 1. So in other words, we divide it by one linear factor, we reduce the power of the polynomial by 1. Continuing this process, we find every polynomial of degree n can be factored in the form of p sub n x of x equals a sub n, your leading coefficient, times all your linear factors, x minus c sub n, x minus c sub n minus 1, so forth and so on, down to your last linear factor, x minus c sub 1. So basically what it says is that you can factor every polynomial down to a linear factors, where these linear factors may correspond with complex numbers. In other words, to solve any polynomial, we don't need to look any farther than the complex numbers. So the real numbers with the number number I, the imaginary number, together gives us a complex number. So that means if you generate any polynomial with real number coefficients, you're going to get, or real or complex, you're going to get, you generate any polynomial, as far as you need to look is for to complex numbers. We don't have numbers bigger, we don't have a group of numbers bigger than complex to solve our polynomials. Zeros and multiplicity. For p sub n of x equals the leading coefficient a sub n and your linear factors all the way down to the last one, c sub 1. The numbers c sub 1, c sub 2, all the way to c sub n will be the zeros of your polynomial. These may or may not be the same. If the factor x minus c appears k times in the factored form, we say that c is a multiplicity of k. So it's just saying these don't have to be unique. You can get repeated factors. For example, if f of x is equal to x minus 1 squared, c sub 1 and c sub 2, those zeros equal 1, so 1 is a 0 of multiplicity 2. For f of x equals negative 5 times x plus 3 squared times x minus 1 times x plus, start over again. For f of x equals negative 5 x plus 3 quantity squared, x minus I quantity, x plus I quantity, we have our first two zeros, c1, c2 equals negative 3, corresponding to this factor here. c3 equals I, and c4 equals negative I. So negative 3 is a 0 of multiplicity 2, while I and negative i's are 0 of multiplicity 1. They occur once. There's an understood first power here and here. The geometric meaning of multiplicity. If c is a real 0 of p sub n of x with multiplicity k, then p sub n of x will have an x-intercept at c, 0. If k is even, the graph will not cross the x-axis. If k is odd, the graph will cross the x-axis. If k is larger than 1, even or odd, the graph will flatten out at c sub 0, or c, 0. The larger k is, the flatter the graph will be near at c, 0. In other words, the point c0, the x-intercept. So basically, it's even means, if you think about it, if you were to go through a door an even number of times, what side of the door you'd be on? The same side you started with. In other words, you wouldn't cross over the x-axis. You just touch it and move on. And then for odd, you would actually go through it. It's like if you went through a door an odd number of times, you'd be on the opposite side you started. Turning points. When the graph is going up, as we move from left to right, we say that it is increasing. When it's going down, as we move from left to right, we say it's decreasing. A turning point is where it changes between increasing and decreasing. Between every two x-intercepts, there must be a turning point. In other words, if you want to go up and you want to switch to down, you have to turn around. And this is for our nice continuous polynomials. Interpretation. If the graph of an nth degree polynomial function has at most n x-intercepts and at most n minus 1 turning points. It may have fewer but not have cannot have more. So in other words, we have a fourth degree in this first example. So fourth degree means that it can have up to n minus 1 turning points, so up to so here we can say it doesn't really turn around, it kind of flattens out. You can kind of say this is a turn here, this is a turn here. So it kind of looks like it has at least, one major turning point, and then it kind of has this point where it kind of stalls out. So it could have up to 3. This one has degree 3. So we can have up to 2 turning points. We can see here, so we have this turning point right here. So if we go up and we kind of want to come down, we're going to go up again. We're going to have those 2 turning points. This graph reflects here 2 real zeros and then a pair of imaginary zeros, right? Well, you can't see them because they're imaginary, but since it only crosses the x-axis twice, to degree 4, 2 of those zeros are imaginary. So here we have, this is going to be an even degree. So it touches right here and then it turns around. So if you have an even number of zeros occurring, and this even number occurs at 2, then you're going to turn around. Here, this is an odd. So this is odd degree. So here we cross. And you notice how both of them flatten out because the degrees are greater than 1. See how they flatten out at on the x-axis. Once again, this 0 is 2 because x equals 2 gives us f of 0 back out, or f of 2 gives us 0 back out. This is g of negative 2 gives us 0 back out because we plug in negative 2. We're on the x-axis. So here we have our exercise. It says consider the factored polynomial. So Hawks will often give you factored polynomials very nice like this. If it's not factored, it usually is a small polynomial. You have to factor yourself. But if these are large ones, they factor them for you. Super nice. So here we have f of x equals x plus 1 to the 4th power, x minus 3 to the 5th power, and x minus 2 to the 1st power. Determine the degree and the y-intercept as an ordered pair. So basically, if you multiplied all this out, you'd have some leading coefficient times x to the 4th times x to the 5th, there are 5 of them there, times x to the 1st. So overall, it would be some leading coefficient times x to the 10th plus, and then you have a lot of left over. Don't actually multiply this out to find the degree. It would take a little bit longer than forever. So it'd be an x to the 10th. So it's degree 10. And we say the y-intercept. Well, the y-intercept's when we plug in 0 for x. So if we plug in 0 for x, we're going to get 0 plus 1 to the 4th power, 0 minus 3 to the 5th power, and 0 minus 2 to the 1st power for our y-intercept. And so if we go here, go to our calculator real quick, and we can say, all right, clear this out. So we're going to have 1 raised to the 4th power, which will give us 1 back out. Can we get this to focus? You're lucky. Okay, so then we're going to have negative 3, so we need parentheses. Negative 3. Refuses to focus. Does it focus better down here? To the 5th power. Then we have 2, negative 2. To the 1st power, so I don't need to do 1st power there. That's 486. It just doesn't want to stay focused on it for any reason. I need to find a better camera setup where I can focus on my calculator better. So actually the y-intercept contains 2 coordinates, 0 and 486. 486 is the y component of your x-intercept. or your y-intercept, excuse me. 0, 46. So next it says determine the x-intercepts for which x crosses the axis. So this is going to be odd multiplicity. So odd multiplicity is going to happen where our powers are odd. So this is powers odd and this one is odd. So determine that it's going to happen 2 times. And the x-intercept is going to happen at, this corresponds to the x-intercept 0, 3. This corresponds to the x-intercept 0, 2. So 0, 3 and 0, 2. So that's where we cross. And it says consider the factor polynomial, determine the zeros flattens out. So this is not asking where it turns around. A lot of students say, oh, well, the other zeros were where we turned around, so let's include those. No, it's saying flatten out. So in other words, it wants to know when the multiplicity is greater than 1. So where is it greater than 1? Well, it happens at 4 and 5 here, so it's going to happen twice. And it's going to happen at 0 minus 1, that corresponds to this factor right here. And also at 0, oops, I need a comma there, comma 3. Now, when you put this into Hawks, remember to separate these numbers with commas and the points themselves with commas as well. If you jam them all together, it won't count them. Some students get that question incorrect because of that reason. So next it wants to graph the polynomial. So we're going to use all information here. And so we're going to have our, so we're going to graph our interesting points here. So the points we need, it's going to be 10th degree. So it's going to 10th degree. So a sub n is positive 1, because if I multiply, and its degree is 10. So that means it opens up like this. It has that shape. So I'm going to start over here. I'm going to end over here. All right, so where do we cross? We're going to cross at -1. We're going to cross at +3. And we're going to cross at 2. And so, or touch, sorry, we may not cross there. So I'm going to have a point here, here, and here. And then I'm going to go by hundreds, 100, 200, 300, 400, and then we cross our y-axis, way up there. So we're going to start over here, and so we're going to go here, we're going to touch the, so let me get a different color here so it's easier to see. So we're going to start our graph, and we're going to come down here, and we're going to touch, and we're going to flatten out at -1. So we're going to touch, and we're going to flatten out. And after we flatten out, we're going to turn back around, and then we're going to cross way up here. Now, I don't know where the peak of this graph occurs. It could occur over here. It could occur to the right side. Probably go to the right side. You need calculus to figure out where it maxes out at, or mins out at for this. Between two, what we call local extrema. That's calculus for you. You'll learn it there. Here we're going to cross through, but we're not going to flatten out. We're going to go straight through. And here we're going to go through, but we're going to flatten out. And so we'd have this very flat portion right here when we cross. And then we'd end over here. So we'd start up here, we'd end over here. And our graph would look something like this if we zoomed out far enough. If you graph it on your calculator, it's probably going to look like a bunch of straight lines because you need to have your y-axis set to really, really large values in order to see it. And even then, it still may look like a lot of straight lines because this polynomial is going to be so big. But yeah, that's what the rough shape is going to look like if you squished it down enough. All right, so next it says construct a polynomial of f of x with the following properties. It's going to be 5th degree. 3 is the 0 of multiplicity 3, and -4 is the only other 0. The leading coefficient 4, linear answer in factored form. So here it just says that we want an f of x such that we're going to have its 5th degree. So I'm going to have a 3, so I'm going to have x equals 3, oops, let me write over here. X equals 3 times. And x equals -4, and we don't know how many times. So x minus 3 is a factor, and x plus 4 is a factor. This happens 3 times. And then here we don't know how many times, but we know it has to be fifth degree. And if it's fifth degree, this has to be 2 to make it. So it has to be 2 times to make it fifth degree. And then it said its leading coefficient, which I don't need another, is 4. So that 4 goes right here. So that's the leading coefficient. Sometimes they'll give you like its y-intercept is a number, and so you have to plug in 0 for x, and then solve for your unknown leading coefficient like we did previously, I think in, I want to say 5.2, 5.1. We did it previously. But yeah, so that's it for today's lecture. One thing with Hawks, they'll have you look at graphs to find the factored polynomial. Just make sure that you have the right degree polynomial you need and it has the appropriate zeros. It's really easy to confuse that you need to, if this is -3, it corresponds to 0, 3. This is +4, it corresponds to 0, -4. So make sure you don't mix that up. Y'all have a great day.